All right, so anyway, hello everyone. Welcome to just about the end of KubeCon. My name is Heather Kirksey, and I am the VP of Community and Ecosystem for the LF Networking set of projects within the Linux Foundation. And I'm going to talk a little bit about sort of how the telecoms are thinking about using cloud native, the journey we've gone to. But I will be really honest, I want to have the most of this session be Q&A and some interactive discussion. I have been here since 9 a.m. Monday morning. I have been in sessions, and I assume many of you have as well. And I'll just be really blunt. My brain's getting fried, so I have to imagine that y'all's brains are getting fried. And the last thing that you really want at 2:35 on day 4 of an event is for a long, dense lecture to be thrown at you. So I hope that you're all sort of excited and willing to play along and kind of talk about cloud native NFV and telecom network transformation. And let's actually spend some time actually discussing some topics instead of just hearing from me. So let me get a raise of hands. How many of you know what I mean when I say the word NFV or VNF? All right, looks like I got the entire telecom crowd in here then, because almost all of you raised your hand. And I'm working on the assumption that for the mainline attendee of KubeCon, that's probably not the case. So, then the sort of framing slides I have are going to be things that y'all know, but I think they're sort of worth throwing up anyway, just to get us all kind of on the same page and maybe take a little bit of a walk down memory lane. So, background and context. So, I think most of you, if you've been in the telecom industry, let me do another raise of hands. How many people here work for network operators of some description or another? Okay, it's about half. How many of you work for network equipment providers? Okay, that's close to about the rest of you. How many of you work for hardware, chip companies or server companies? Okay, and how many of you for application or software distro vendors? Okay, all right, so we've got sort of the general mix. So my background has been mainly in the telecom industry. I worked for Alcatel-Lucent for about 12 years. For a while, I ran standardization for one of the business units within Alcatel. And then my last couple years, I worked for our IP division, which is the group that makes the big iron routers and switches. And this is actually a slide from that time in my career. And it's a bit of an eye chart, and that's sort of the point. So this was Alcatel-Lucent's high leverage network, circa 2010, with sort of LTE and fixed line networking, and your IMS, your eNodeBs, your Evolved Packet Core. And the thing that I think we all realize at this time is this is a lot of boxes. A lot of special boxes that do special things and not a lot else, right? And so that was what caused all of us to kind of go towards NFV, right? Let's try this in software. So we started, so there was a group started in Etsy, the Etsy NFV ISG. So how many of you were part of the Etsy ISG at any point in your careers? Aha, okay, we've got software people then. So the thing about the Etsy diagram is it was an attempt to start thinking about moving to general purpose compute, general purpose hardware with open source software providing the intelligence to run the network. And this is the diagram of the architecture that Etsy designed. And what's the first thing you notice about it? It still looks like boxes. So, in the telecom world, that is very much how we tend to think about things. We think about things in terms of network elements and boxes. They hook up, they deliver connectivity services. We don't we have in the past not traditionally thought like software designers. And that's one of the things that's been changing. So the reality of that was not so much that it was a series of special boxes, but this was sort of what the integrated stack, sort of with some of our early attempts at virtualization look like, right? So we had hardware, and we were moving to more commodity vanilla hardware. We had the things like OVS and DPDK and FIDO, performing virtual switching functions. We used initially OpenStack, very VM-centric, with one of your favorite SDN controllers in there. And I have OpenBaton on there. This is a bit of an older slide, but obviously OnApp being one of the big orchestration, back office, OSS, BSS kind of reimagining. And so, we started down this path of virtualization. And one of the things that I think became true for a lot of us was that the applications were not really cloud applications a lot of the time. They were the code from the existing network elements thrown into a VM. Woohoo! So we weren't really getting a lot of the value that we could out of moving to these cloud architectures. Networking was so very complicated to set up. We couldn't, leverage things like the scale-out capabilities because we'd really just recreated monolithic hardware code inside monolithic VMs. So, a number of different groups within LF networking kind of realized that and have started down the journey of, thinking about getting things cloudier, and we did a lot of things over time to sort of help that. One initiative is we actually started doing CI/CD. We started implementing some of these modern development practices within our open source organizations. And we actually started connecting our CI/CD pipelines. We started doing things like getting tip of master from multiple projects, integrating with them each other, and getting feedback and fixing bugs faster. We started inserting things like automated testing and automated gates and deploying to different types of hardware infra that mimic the different types of things in the service providers. Some of the operators actually started implementing DevOps principles and practices and CI/CD in their own environments. So if you are a network operator, are you implementing or using CI/CD in your network? Okay. A few scattered hands. I know some of our operators have actually started moving that direction and are actually seeing a lot of the benefits that people talk about. They're able to get changes more regularly. Things are more stable because they're not waiting to do big upgrades. They're able to actually start working with their suppliers and actually getting their suppliers to send them more frequent updates using sort of collaborative CI/CD tool chains. So it's really cool. We are, as an industry, beginning to move closer and closer to some of these cloud-native principles. This is a slide of the testing projects from one of the LF networking projects, OPNFV, but the testing projects have really started investing in automated testing. And having that in there, it's smoke testing and different testing gates and things that really start to look like modern software. We've also started partnering with CNCF on a number of fronts. So who was at the CNF BOF yesterday? All right, a couple folks. Those slides are uploaded. I definitely encourage folks to look at those. And that sort of details some of the partnership that we're doing with CNCF, beginning to actually test, VNFs, which are virtual network functions, and CNFs, which is the cloud native counterpart. Seeing how seeing how they work in a number of testing scenarios, seeing what the advantages are if we can really get better performance from cloud native, and right now it looks as though we are. So then the question is, we've started doing some of this proof of concept. We've started implementing some of the processes that really support cloud native, but what does it look like if we really want to really go there? And so, and this within the LF networking set of projects has really led to work kind of in different areas. So we had a FIDO mini summit on Monday where we talked about a lot of the things that FIDO is doing with respect to cloud native things and being a really high performance data plane for cloud native applications. OnApp can now be deployed in a containerized fashion. OPNFV is beginning to look at what does the cloud native NFVI need to look like. And our SDN projects are also kind of beginning to think, what's their role? And kind of with that, I really would like to move to some open discussion. I have some questions that I think that are things that I've started thinking about, but I would love to hear questions that y'all have and maybe actually start to get some dialogue, make sure we stay awake through these last couple hours of our conference. And the first one that I sort of wanted wanted to throw out there is, because I have done so much work with NFVI stuff for the past 4 years, what does the cloud native NFVI look like? Which CNCF projects do we want to bring together? I mean, Kubernetes, obviously, but how do we want to do networking? There's been a lot of talk this conference about network service mesh, things like Envoy. Is Istio a useful control plane for telecom? Are there folks out there who've started experimenting with any of that? So this is I'm going to put y'all on the spot now. So if you were hoping just to sit quietly, I'm going to try to push you not to. So anyone have some thoughts? And I will just start picking on people in the audience that I know that might have thoughts on some of these questions. So, what are folks thinking about for what the cloud native NFVI needs to look like? What is the right set of infrastructure components from CNCF?
Depends on your workload.
And by the way, we do have microphones, so they're in the middle if you don't mind talking into those, or we can just pass them around. Actually, do one of you mind sort of running microphones around unless they're wired into if they're wired into the little stands, then not, but, okay. Okay, cool. Up here at the front. So I think you were just saying it depends on the workload. So do you want to talk a little bit about your sort of things that you have found?
So you heard me complain about this yesterday, about the very weak standardization around the VNF space. So I think some of those questions would be easier to answer if we had standards around CNFs. Like, these are the API interfaces we want to expose. These are how the different layers are going to interact. As far as, though, which tools I'm going to pick, like OpenStack tried this and then failed at it because the first word was open, but then you had to deploy 15 services that were all interdependent upon each other, and the openness of that stack started to diminish. So I would say one of the things that we should strive for is to keep this actually open. So if I'm doing cable stuff with Cloud CMTS, I can build the stack that works for Cloud CMTS. On the flip side, if I'm doing telco stuff, I want to be able to build a packet core that does what I want it to, not what I've shoehorned into somebody else's vision of what a platform should look like. My question for you is OnApp was designed from the legacy Etsy framework, like it's very mano-centric. How do you see OnApp evolving to adapt to the world of CNFs versus VNFs?
Yeah. I think that is a very good question to which I do not have all the answers. But one of the things that seems fairly immediately obvious to me is a lot of what OnApp has to do is related to a lot of the sort of complicated wiring amongst, to set up the network, to do the VLANs, to get the VNFs, sort of properly configured, to set up all your OpenStack networks and things like that. I think one of the first things that can happen is that OnApp can become simpler, honestly. Because it won't have to do as much complicated work, that more of that can be can take advantage of what gets built into sort of the CNF infrastructure. That's sort of my first take. And that it can, sort of, rather than having to spend a lot of complex time around a lot of complicated network sort of configuration, leverage the network and focus really more on the, kind of telecom service management, the application design center, getting lots of details in and integrating with something like Panda to do really interesting, AI and machine learning around kind of the network health, network stats, how the services are actually working. But that's just sort of my opinion. But that's sort of how I kind of see it.
Yeah, I can address one of the questions there. I work in OnApp. In the last Casablanca release and upcoming Dublin release, we are trying to, as you guys may know, that OnApp today can only talk to OpenStack-based cloud regions to deploy VM-based workloads. But in R4, release 4, which we are starting, our intention is to support Kubernetes-based cloud regions to basically bring up both the VM-based workloads and also container-based workloads. The way we are trying to do that is VM-based workloads, we intend to use Workload today, which works along with Kubernetes to bring up VMs. And of course, Docker is there to bring up containers. So you should check out OnApp K8s cloud region support.
Cool, great. All right.
I have the mic.
Vivek from AT&T. I think it's also important for us to understand that, this is more of a comment, it's important for us to understand that for telecom, not everything is packet processing gateway. So there are control plane elements like MMEs and PCRFs, which are a lot easier to make cloud native. So those might probably be better targets initially for us, rather than always think about high packet processing, VPP-like applications, and tie telecom to only packet processing. So there is the control plane category of applications which are a lot easier to make cloud native, and those would probably be more pragmatic approach would be to start with those first.
Great. Yes, right there.
Speaking from the operator space, so far, I felt like the NFV approach has not addressed any of our network team's concerns at all. You know, OpenStack looks like something designed by a bunch of software people that networking people have no interest in touching. And spinning up a bunch of VMs has nothing to do with solving their problems of configuration, which is what software-defined networking is for them. It's configuring a bunch of routing elements to enable services to flow across our network. And they need tools like netconf and Yang and consistent interfaces to use those tools.
All right, so I think what you're saying is kind of in the move to sort of the more software-defined architecture, sort of the ability to consistently apply configuration to these sort of software apps that are now providing the functionality that router boxes and things like that used to apply hasn't necessarily gotten a lot easier. Is that, yeah? And yeah, I think you've.
I had a question more along the lines of the community and how priorities are set for the VNFs or CNFs and features. So within Kubernetes.
Actually, do you mind if I pause you right there? Because I want to sort of address kind of that statement or question because, and I'm going to actually maybe look at Frederick. Because I know he and I were having a conversation yesterday actually about how Open Daylight has the strong ability to do netconf, and as we are implementing a lot more things in software, how are we able to still kind of get our network out of it, not make things more difficult than they used to be. I mean, I would sort of have an initial comment on that that is what a lot of OnApp is trying to do, right? Which is to consistently onboard and configure the services and the applications. And so if you were thinking about, sort of your router as, your VNF or your application, the ability to manage, configure, onboard, and deploy, sort of that router application is a lot of what OnApp is actually sort of addressing there. But Frederick, do you have any thoughts? Because we were talking about kind of the role of netconf and a lot of ODL type things in Cloud Native yesterday or 2 days ago. I have no idea what day it is at this juncture. I'm not sure about the rest of you.
Yeah, I don't know what day it is either. I'm going to keep coming until no one's here. But anyways, yeah, to drive down, I think what you're saying is incredibly important. So when you start looking at most networking solutions that, whether it's OpenStack or Kubernetes or so on, they make one very important assumption, which is that the underlay is already there. So they already have connectivity, so they're going to build connectivity on top of something that's already there. So that's where it becomes very important to bring something, it could be Open Daylight or NSX or some other similar set of projects that are capable of driving and doing those initial configurations, actually establishing that initial connection, and then you can start building on top of that. And that's an area that I feel has been quite neglected by most of the software industry at this particular point, but it's incredibly important to solve if you actually want to build the infrastructure for a telco. So if you are a software network developer in this space, start thinking about that problem. And there's a lot of problems that we have to work through in order to make it possible for you to implement what you want through things like netconf, maybe using Yang to model or other well-known tools. So excellent point.
Cool. All right.
Oh yeah, back talking about governance. So when you're dealing with features within the Kubernetes space and CNCF, there's a way of determining things through SIGs and working groups in a democratic fashion, and the people that have an interest in certain features being pushed up, they jump in on these meetings. And so when I'm hearing about pain from certain features not being put in the different projects, I'm wondering if that model, the Kubernetes model or CNCF model for governance, would help with some of these, like, it sounds to me like features being pushed up versus from users versus maybe vendors or something like that.
Yeah, so in terms of how the governance works for these projects, it's not dissimilar from Kubernetes, although we don't have the SIGs. Typically here, and let me go to our set of projects just so everyone can see them. Typically the way they work is each of these projects has a technical steering committee and then sub-projects underneath it that usually sort of come in to address some feature area or function area that someone feels is of an issue. And a lot of these actually are started and often led by the end users as well. So we do try to get them involved in the developer community, even if they're not necessarily doing the coding. They're sort of driving the feature realization. But one of the things that I found, for being all very honest here, is that we'll sometimes have a gap in between sort of the understanding of sort of a pain point from an operator and maybe the software developer's implementation of the feature and whether that makes sense. And we are trying to, I think, close that gap. One of my goals for 2018 that I did not meet was to get a pan-LF networking end-user advisory group up and going. We had one in OPNFV and we had one in Open Daylight before we brought all these projects together under the umbrella. And sort of getting that spun back up so that we do have a better feedback loop between our end users and what's getting implemented in the communities is really happening. But we do tend to be pretty lucky in that because a lot of this is so core to a lot of our network operator members, they tend to actually participate pretty deeply in our architecture design plans and as project technical leads, kind of across the projects there. But it obviously can be better and things always can be improved, and I think getting our end user advisory group spun up and more deeply involved. The other thing that happens too is we tend to get a lot of folks from our operators who are more in the R&D side and architecture side, kind of more CTO office types, and we're definitely seeing the operators, and I think it goes to the point the gentleman just made there about sort of your needs is that we need to get better about hearing from operations people who are actually deploying some of this stuff and what pain points come out of operations as opposed to sort of, we hear a lot from operators, as we're designing and getting things done. But, as is true in all big companies, sort of the needs and desires for cool features versus some of the needs of the operations folks who actually use, manage, and deploy this don't always marry up either. And so we're trying to figure out how we can get better input from the actual ops people within the carriers, and not only from kind of the design people too, which is not to say anything bad about anyone, but you get different feedback, right, from ops people, and we're trying to address how to get more information from that side of the business as well. Does that make sense? Cool. All right. Any other questions before I can start posing some of my questions back to you? Yeah. Thanks, Frederick.
So I just found out about the network service mesh yesterday. What involvement has network service mesh had with this SIG?
Yeah, so network service mesh kind of grew out of a presentation at ONS, which is kind of the big summit that these projects tend to have every year, and actually sort of came from the TSC chair of FIDO. And sort of thinking about as he was looking at sort of deploying FIDO as a data plane in cloud native land, sort of seeing the sort of that gap that was still there. So there's actually a fair amount of overlap between Open Daylight development teams, the FIDO development teams, and the Network Service Mesh development team. So Network Service is a project here in CNCF, but it's actually a lot of the similar developers who've been working on some of these problems within Open Daylight and within FIDO for the past several years. And you actually have one of those who works in Open Daylight and FIDO to some extent too, no? Okay, a little bit of FIDO and Network Service Mesh, so. Yeah, all right, any other questions? So I think, we started touching on this, but I had a really specific question that I know one person I would like to answer that, but also, how do you see the role of SDN controllers over time in cloud native? Because there are definitely sort of cloud native ideas around, what control planes look like and things like that seem somewhat similar to the problems that we've been addressing with things like Open Daylight and SDN controllers, but maybe different approaches. And I'm just very curious, those of you who've started experimenting with cloud native and who maybe had implemented SDN with SDN controllers in the past, how are you beginning to think about it? How are you looking at sort of those features and some of the so those different network programmability concepts?
So I'm being asked to give a response, I suppose. So let's talk about you mentioned about Open Daylight before with netconf and so on. So when we started looking at network service mesh, one of the things that we realized is there was a gap between trying to ask what you want, what type of cloud native networking was there in terms of the APIs. And so we decided to try to focus on how to bring in other things as well. So suppose that you were running suppose you had some fabric and you wanted to control it with Open Daylight and you wanted to set up maybe some cross-site connectivity through a VPN. Using Kubernetes APIs and what they provide you, how do you do that? So you're going to end up cobbling something together yourself, custom management scripts and so on in order to try to do this. And so what we're trying to do is we're trying to set it up now where you can have a common set of APIs that are easy to pull in the type of things that you want to provide that type of connectivity. So things like Open Daylight and other projects, I'm trying to get Tungsten Fabric pulled in, trying to get others as well. And part of what we want to do is make it very easy so that you use whatever you want to use, the others use whatever they want to use, as long as you can both speak the same tunnel protocol or encapsulation, we can find a way to make them work together. And so we're trying to help provide that overall, think of controller of controllers, I guess, the best way to describe it. And so we're trying to set it up so that these various entities have a way to have an entry point so that when someone wants something while they're in a pod or they're in a cloud native environment, then they can get the thing that they want through a very simple, very specific way, but still with all the nuances wired in that you may have through configuration, through rather than trying to program a script or trying to program a specific path.
So every provider kind of tries to skin this cat differently. And I can tell you just in my space, I work with 4 different SDN controllers. So one of the things that we've been trying to do is actually simplify the transport itself, remove the number of protocols that we're using, start looking at technologies like segment routing, specifically SR-MPLS and SRv6, and then also trying to cut down the number of encapsulation types that we use.
Right.
So we've been looking at terminating MPLS directly on the vSwitch or through SRv directly on the VNF itself. Because the thing that, if you don't come from the service provider world, you just don't understand the magnitude of crap that we have to deal with. Even if you...
It's so true.
Well, even if you're there's enterprise customers that have networks that are probably close to the size of ours, but it's like a single ASN, right? In my network alone, I'm going sometimes across 7 different AS regions. I've got, 4 different encapsulation types. And so what SDN controller does all that for me? When I go from access to my core to my data center, It's 3 different networks. It's 3 different SDN controllers because those networks have unique needs. And so protocol consolidation and encapsulation consolidation is a big thing. And then the other thing we're doing is we're trying for 2 other things. Is every single vendor that comes to us, we want them to have some type of data modeling support. So I don't want to program my network. I want to model my network. I want, and it's similar to what Kubernetes tries to do with Solve, right, with its declarative models. But we use Yang and Tosca, right? It goes directly to your point, is when I bring up this VNF, if the VNF does not support a certain type of modeling template, we throw them out. Because I've got my models, and all I should have to do is change some host names and some interfaces and this and that, and you should at least be able to take about 90% of what vendor Y is doing in vendor X. And then the other thing is common northbound API. Because we have so many SDN controllers, we have been working internally on basically creating an OSS layer where, I hate using the word intent because it's the new buzzword in the networking world, but that's kind of what we try to do is we have all these different controllers sitting southbound because every part of our network has a unique need. I mean, you showed it in your Alcatel slide, right? All those different boxes existed because they're all doing very different network functions. And just because you put it in a VM, I now just have 30 different VMs that I have to manage differently. So we try to force vendors to give us this common API on the north side, so that way our OSS layer, I just put intent down if I'm in operations, and then there's some type of translation to the different types of APIs that need to be called southbound for those controllers.
I mean, you're not looking for the equivalent of an EMS for every single box out there the way things used to get sold?
You know my opinion on the Etsy framework that you showed earlier.
Yeah, I worked on EMS for a little while too. So, the fact that we didn't get common data models for a lot of, EMS network appliances, I think was one of the things that we sort of failed at as an industry, and I don't want to see us fail at it again, through software. And I have, we're getting close to time, but I have one more question that I'd like to ask, and it sort of follows on a little bit from that, which is, hearing about things like network service mesh, seeing that, maybe with service mesh, network service mesh, a lot of perhaps some more of the network configuration can be done by the infra as opposed to the application or the application service. As we move to cloud native, are CNFs really just applications that we as sort of the telecom industry happen to use? Or do we think that there are things that remain particularly special about sort of the CNF applications that we see ourselves deploying in the network? And to me, it's an interesting question that I don't know that I know the answer to, and I'm not sure I've heard an opinion sort of expressed, but yes.
Yeah, I think there is a difference, for the CNS, for the telco world. There's a couple of things performance is one of them, and access to the packets is another one. So I think the telco kind of CNFs probably require different level of access to packets than the regular ones. I think that the network service mesh, I think, is the whole basis of that is that's the thesis behind doing something different. Otherwise, we could be just fine with kernel interfaces.
Yes.
Yeah, I'll argue on the other side of that comment that we in telco, we try to always think that our workloads are kind of special, and in some cases they truly are. But as Vivek was saying earlier, that in a lot of control plane workloads at least, if we give it some effort, we can think of the workloads as just an application, as you were saying, and try to work with it in that manner. There are, of course, cases where we need direct access to the packets from the kernel. So that doesn't rule out any of the good things that we can take from Kubernetes that way, I guess.
Yeah, fully agree.
Yeah.
There is control plane workloads. I fully understand they're like any other applications, but there is certain things which do need unfettered access to packets.
Correct,
at a specific rate. So her question was do we need anything different? I think the answer is yes. But in most cases, we can just do with cloud native applications like everything else.
Correct. And the other point is that we have to fundamentally see that Kubernetes is a way to orchestrate workloads. And we have to clearly define in the telecom space what is our workload. Is it doing a session management for us? Then that's the workload. It can't be all things to all people, right? We can't think that Kubernetes can solve the orchestration problem of the networking devices or the configuration of different networking devices, because it's designed to be a workload orchestrator, not anything else that way.
Yeah.
All right, and I think you are our last question because we are at 3:10.
Okay, more than a question, I just wanted to.
Yeah.
I mean, I feel that any networking workload can be CNF, right? I mean, for example, as I mentioned, I work in OnApp, and there is a big especially there is something called data plane VNFs, right? Data plane CNFs, which require multiple network interfaces. It needs to belong on multiple networks, and then sometimes it requires core affinities, core dedication, NUMA awareness, and many things which are quite well thought about in OpenStack VNF world, but things are not there in CNF. Again, as part of that OnApp K8s work which we are doing, we're also enhancing facilities to bring those kind of good things to Kubernetes and CNF world. So I just wanted to mention that.
Oh, thank you. All right, so we are done, and thank you all for playing along, getting involved, making this a participatory event, and I hope that you all have very safe travels home, a wonderful holiday season, and that you have had a productive, useful, happy, and fun KubeCon for the past several days. So, on behalf of the Linux Foundation, thanks for being here, and thanks for participating. And some of these questions I'm asking, I did have a little bit of a a method to my madness, in that these are some of the questions that we need to answer and that we are answering in these projects. So if these are things that you're thinking about, things you have to get answered, things that are confusing to you as you're looking at your cloud native transformation for NFV, please come get involved, please come participate, and please come help us figure out the answers that meet our needs together. So with that, goodbye.